Okay, so I've actually decided to break up our exponents lessons into concept and examples because there's quite a few and I want you to be able to pick and choose exactly what video you want. So this lesson is just going to be on exponent examples using the product and quotient properties. Let's look at the first one. All right, so our learning objective for this one is, again, we are going to apply the exponent properties, right? And I have the exponent properties listed down here at the bottom to help us remember as they come up. Now, these problems, we're going to read the directions, be very careful to understand exactly what the directions are telling us, even if it's only one word. And then we're going to use our order of operations in order to do whatever is either simplify or evaluate these. So first off, this one says simplify. Now, remember what simplify is telling us to do. Simplify wants us to do any of the operations that we can in order to put all of the numbers and variables together into as few of terms as possible. So I want to combine 4 to the third and 4 to the fifth into one exponent. All right, now let's go through our steps here. Step 1, identify exponential expressions that have the same base. I see that I have 4 to the third times 4 to the fifth. Yes, they have the same base, so therefore I can use the properties. So now that I see that I have the same base, let's go to the second step. Determine which property of exponents to apply. Well, I see that there's multiplication. So I have to remember, okay, when I'm multiplying exponential expressions, I need to add the powers. Now, this is the only work that you really need to be able to do for these problems. I simply am going to see 4 to the third times 4 to the fifth, same base, add the powers, 3 plus 5 is 8. So 4 to the 8th power is what I should have for this example. Now, I want to give you a little bit more understanding than that. So let me expand these out and show you how we end up with 4 to the 8th power. 4 to the third means that I'm multiplying 4 times 4 times 4. That is being multiplied times 4 to the fifth, which means that I have 5 of these 4s all being multiplied together. Now, notice that there's multiplication in between every 4, including in between the groupings. There's multiplication in the middle right here. That simply means how many 4s do I have altogether being multiplied? Well, I can just add them up. How many 4s are there altogether? 1, 2, 3, 4, 5, 6, 7, 8. That is why I'm allowed to add the powers. If I expand it out, I will see that I have 8 4s being multiplied because there's 8 of these. 1, 2, 3, 4, 5, 6, 7, 8 of them. I know to change that power to 8. Okay, so like I said, everything down below is just extra work. Really, we just need to remember the property is add the powers. Now, let's look at the second example. Here we says simplify, and I see that I have a fraction, 5 to the 8th divided by 5 to the third. Okay, so let's again see that I have the same base, 5 and 5. I can use my exponent property here. I see that there is a fraction here, which lets me know that division is happening. That's how we show division with exponent properties like a fraction. So now I can know I can use my exponent property down here. Dividing by exponents, I subtract the powers. Always remember, you do not subtract the base. The base must stay 5. I simply subtract the powers. So here is all I'm going to end up with is 5 to the 8th minus 5 to the third. Let me actually write up a little bit of work. I'm going to subtract the powers just like this, 8 minus 3, and I end up with 5 to the 5th power. Now, like last time, I want to expand that out a little bit and show you that 5 to the 8th means that I have 5 8s divided by 5 3s. I cancel out 3 of them, and I'm left with 5. In fact, I think that's simple enough. I can just leave it at that. If you didn't understand what I just explained, go back and watch the concept video. There's a couple more examples. Let's look at a more in-depth one. Now, don't be alarmed by these. Let's not look at this one yet. They are getting more complicated, but it's not so complicated that we can't do these. So again, we're applying the exponent properties. Let's go to read the directions, simplify. Okay, so if I need to simplify this, I want to put everything together that I'm allowed to. Step 1, identify exponential expressions with the same base. So I see 3 to the 6th times 3 to the negative 4th divided by 3 to the 5th. They all have a base of 3. Excellent, I can apply my properties. Now, second step, determine which property to apply. Now, this is where people can be confused, but follow your order of operations, meaning multiply, then divide by whatever you see going left to right. So when I look at my expression here, I see 3 to the 6th times 3 to the negative 4th. Well, on the numerator of that fraction, I see that I can easily just multiply those two things together. So let's simplify the numerator first, and then we'll do the denominator. How we approach these is we simplify little pieces at a time so we don't get confused or make mistakes. Let's simplify the numerator. I'm just working on this part right here. Oh, actually, I see I have a negative exponent. Well, with exponent properties and positive and negative exponents, we just treat it like a normal negative number. So let's see what we end up here with. 3 to the 6th times 3 to the 4th. I see that the powers are being multiplied, right? So if they are being multiplied right here, that means I need to add the powers. All right, so let me go ahead and write that out a little bit. 3 to the 6th plus negative 4 plus a negative 4. Let me clean that up a little bit. Plus negative 4, and then that would be divided by 3 to the 5th. Okay, so let's go ahead and do that little calculation. 6 plus negative 4, they're opposite signs, so I subtract them. 6 minus 4 is 2. I have more, 6 is a bigger number, so it stays positive 2. So now I'm going to switch colors here to show you that I've simplified the first step on the numerator. I now have 3 to the 2nd power divided by 3 to the 5th power. Okay, so hopefully you follow along. I added the powers, but one of them was negative. That's how I ended up subtracting them. So like I said, we were just subtracting the powers. So 3 to the 2nd power, I see subtract division, so I know to subtract the powers. And then now I have to just subtract them. 2 minus 5. Well, 2, starting at 2, and I'm subtracting 5, I'm going to have to go into the negatives. So 2, the difference between 2 and 5 is 3. 5 is a bigger number, so it should be negative 3. So I'm left with 3 to the negative 3rd power. Yes, we can have negative powers, and we'll talk more about what those are in a second.